sure please make sure your microphone is muted and feel free to leave your camera on. I just wanted to say it is going to be recorded, but we will stop the recording before the questions, so you don't have to feel shy about asking questions later on. And it is my pleasure to introduce today's speaker to you, Clara. Colombatto. I hope I pronounced that well.
Yeah.
All right. Clara did her undergraduate at Duke University and is currently finishing up her PhD in the Department of Psychology at Yale University with Brian School. She also collaborates with Molly Crockett and Ilker Ididrem, and her research focuses on the visual roots of social cognition. So she works on the very exciting interaction between perceptual neuroscience and social psychology. And today she will be talking to us about perceiving perception and attending attention. Clara, the floor is yours.
Thank you very much. Thank you, Steve, for inviting me. Thank you, Matan, for coordinating all of this, and Nadine for the introduction. Before I start, I just want to say, please feel free to interrupt me at any point with questions. I've decided, rather than picking just one or two projects and explaining everything about them, to pick to kind of give you an overview for what our work looks like. So I'm going to be going through various paradigms, various studies, and I'm not going to be telling you like how big the stimuli were or how many trials were in each experiment. So if you're interested in any of those details, I'm happy to chat about those. So please feel free to ask questions. I can see you, so you can wave hands or raise hands or do anything you need to do. Okay, so today I'll be telling you about work we've been doing on perceiving other people's perceptual states and attentional states. And I like to start this by motivating the reason why we're interested in this, which is that other people are probably the most important thing that we can perceive, but not all parts of other people are equally important. So you don't usually recognize people by their legs or their arms, but rather by their faces. But even when looking at someone's face, there's some features that are more important than others, and in particular, other people's eyes. And in fact, other people's eyes have been studied a lot in cognitive and social psychology, and there's all sorts of effects that the perception of other people's eyes gives rise to. So for example, other people's eyes capture your attention, they enter faster into your visual awareness, they hold your cognitive control, you find them faster, you remember them better, and it influences even higher level things like how long things seems to last, or even how attractive people look is determined by whether they're looking at you, or in part determined by whether they're looking at you or looking away. Now, most of the work in this domain has taken the eyes to be so meaningful that we've evolved some sort of mechanisms to really be sensitive to those, and in particular to the visual features of the eyes. So for example, the fact that there's such high contrast between the dark iris and the white sclera makes the eyes such powerful stimuli in social perception. But we actually think that that's not right, and that what's really driving social perception is not the perception of other people's eyes, but rather the meaning behind them. So the fact that there's a person attending and a person that's perceiving behind those eyes. And so we think that all of these effects of eye contact and gaze perception are really driven by, are not really eye contact, but really mind contact, are driven by the perception of agents and of minds behind those eyes. And to demonstrate this idea, we use two approaches that I'll talk about today. One is experiments where we investigate minds without eyes. So the idea here is that we still convey in some sense the intentions and the attention, but without the precise stimuli that are the eyes. And then in other types of experiments, we take the eyes and we strip away the intentions behind them. And so these two approaches combine to us really point to the idea that it's the intentions and the attention of other people that drive our percepts, and not really the visual features that we see when we see other people. And so I'll go through a series of experiments that take these two different approaches, and I'll start with the minds without eyes. So the idea here is that if it's really the intention and the attention of other people and not really the eyes, then you should see the same effects that you see with eye contact and with eye perception with stimuli that don't have eyes at all and look nothing like eyes, but still signify the intention and the attention of other people. And I've been doing this work with so stimuli like these that signify intention and attention, we designed the stimuli in Blender that still convey intentions, and we call them the mouths. So the idea here is that this still has a very clear sense of intention and direction, but of course they look nothing like eyes. And I've been doing this work with Brian and with Ben Van Buren, who used to be in the lab and is now a professor at the new school. And so what we did is we took the stimuli and we plugged them into existing experiments that had been shown with eyes, and we showed that you get the same effects when you don't have eyes at all, but still have intention and attention. And so one example of this is working memory. So the tasks here are very simple. You see an array of shapes and then it goes away and then it comes back, and the task is, did something change? And you have to say whether shapes change or not. The key is that you're doing this task while there's also some agents on the screen that are in some cases looking at the shapes, and in some cases they're looking at you directly. And the main finding is that people get worse when you're doing this task when there's people directly staring at you while you're doing this. And this actually might have happened to you, that you're like taking an exam and the professor is like staring at you, and it distracts you from doing that. Okay, so what we did is we took the same exact paradigm and we replaced it with our mouth weird stimuli. And these are the results with the eyes from previous papers. And what we find is that we get the same exact results with the mouths that look nothing like eyes, but really still signal the intention and the attention of people behind them. Now, you might be, this is just a direct replication. You might be thinking, well, of course, these look very different. There's more color in one, there's more space occupied by the mouth in one. So we just ran a control where we cover up the mouth, and then the effects completely go away. So we think that this is initial evidence that it's really not the eyes that are driving effects like these, but it's really the intentions that they signified. Now, we wanted to take this one step further and say, okay, well, the mouths, maybe because they occur so closely with the eyes in general, people are still imagining the eyes or somehow filling in the eyes above the mouths in those stimuli. And so we decided to take this one step further and take away faces at all. So see whether it's not just mind without eyes, but minds without faces that elicit these effects. And for this, we focused on another class of effects, which is called the stare in the crowd. So here, the idea is that you're searching for faces that look in a particular way. So in some cases, you're looking for a face that's looking away and is surrounded by faces that are staring at you. And in some cases, you're looking for a face that's looking at you while everything else is looking away. And the main finding in this type of experiments is that someone who's staring at you pops out in visual search. And this might have you might have experienced this too, when you're like in a crowd and you just see somebody who's staring at you, and you will find that more easily than finding somebody who's looking away. And so in this case, we didn't do it with the mouths, we did it with stimuli that look nothing like faces at all, which is some cones that are pointing either towards you or away from you. And what we get is the same results as before. So you can do this both with response time and with sensitivity, and people are much faster at finding the cone that's pointing towards you when everything else is pointing away, and they're also better at finding the one that's pointing away. And again, this is just a direct replication of this. We also ran some other controls. You might be thinking, well, here one is symmetrical, one is not symmetrical, one has higher contrast, one has lower contrast. And so we ran these other controls where the task was exactly the same. So find the symmetrical one, find the asymmetrical one, and we matched all the colors to be like the cones. And what we find is that the effects for symmetry reverse and for the contrast are completely null. So we control for these other factors as well. So the idea here is that, again, it's not really, if you get the same effects with stimuli that look nothing like eyes or even like faces, then it should really be the intentions and the attentions that they convey behind them. Now you might be thinking, hold on, are you saying that a cone is intentional and looks alive? Well, I'm actually going to skip this section for a second. So We actually took inspiration for the cones from the art of Andy Goldsworthy, who's a British land artist. So what he does is he goes around and rearranges materials that he finds in nature to leave traces of agency. And so this is one of his pieces. And the idea here is that it's the coordination of multiple objects that gives rise to the perception of intention. So if you see one cone that's pointing at you, that could be just by coincidence. But if you see all of them that are coordinated in pointing at you, then that does give rise to the impression that some agent was present and rearranged the materials. And he does this with all sorts of pieces. So with branches, this is my favorite because of the symmetry. I think is amazing. Anyways, I also wanted to mention some follow-up work that we're doing in this domain, which is that one interesting thing about these pieces is that they still convey agency, but the agent isn't there. And we think that this hasn't been explored before. Usually in studies of agency, the agents are there. And so you're perceiving, even in our math and in our code, you're perceiving something that is on the screen and is very much there. But actually in our everyday life, most of signs of agency are traces of agency, are things that are in the past. So for example, when you are hiking and see a cairn like this, of course, this has been built. You have this automatic impression that somebody has built this, that somebody has left this as a trace of their presence in the environment, and we think that this is a very powerful stimulus because you readily perceive the presence of another agent, even though, of course, they aren't there. And people, there's like actually some funny things that fall into this realm. So, for example, in Chicago, people leave stuff outside their houses to signal that other people shouldn't park there. And this is another example of people leaving traces in the environment, and you readily perceive that somebody had an intention and is sending a message by leaving something there. So that's just some work that we're doing now with Michael Lopez and Julia Hara-Enninger, where we show people block towers that have that either look like they have been stacked by agents or look completely flat, such that it's very unlikely that somebody would have stacked them exactly like that. And we're finding the same exact effects that we find with the cones and with the mouths and with the eyes, which is that people readily detect the signs of agency in the way that they don't when the objects look completely inanimate. So I'm going to move on to the second part. If there are any questions, I'm happy to answer them.
Can I ask a quick question, Clara?
Yeah, definitely. Thank you.
I was wondering about the cones. I'm sure you've considered this. So your favorite explanation in terms of an agent that may or may not be there. What about an explanation in terms of a cone pointing towards you is more important because it might be something coming at you, something coming towards you may have to deflect or do something else with.
Yeah, definitely. So so I think that there's the two ideas that you're pitting against each other, the idea that something has an intention and the idea that something is coming towards you might be actually very related. So the idea is that if you're perceiving something that's looming, that's coming towards you, you also get the percept that there's an intention or attention. We think that the fact that there's an intention or attention kind of lies at the root of the sort of percept that you're mentioning. And the idea is that to be able to perceive something that's coming towards you, you have to perceive that there's some sort of intention or directedness. And that's what we're trying to get at with the cone. So the idea is that there is a phenomenology of feeling like something is coming towards you, but really at the root of that, there's also a percept that something is intended towards you or directed towards you.
Okay, I take your point. I guess they're not 100% necessarily correlated, right? Something might be coming at you without that being an intention behind that. But yeah, I think your point that often they would be correlated. Thanks.
Yeah. I see a question from Wayne.
Hi, thanks. It's really interesting. Can you show the slide that the data slide again from the memory, intention, and distracting task?
Yeah.
Sorry, I have two screens on and you're seeing my chin. My question was, it looked like you might be getting, so in the directed case, you're more sensitive in the averted case. Yeah, okay. So I was curious, have you done an experiment where you have the faces pointing away? No, so not at you, but averted away from the objects? Because I was wondering if you're getting like it's almost like a valid cue.
Yeah, absolutely.
There. So maybe you could test like an invalid cue where you have the mouths pointing away from the.
Yeah, that's a great question. So I personally haven't. I'll show some other experiments later where we do those sort of controls. In the context of these experiments, the original papers that we were replicating have, and you don't you don't get a difference between those conditions. So it's really the sense of avertedness regardless of what it's being averted to. But that's really important in the experiments that are coming up later. So thank you for bringing that up.
Thanks.
Okay, so I'll move on to the second part of my talk, which is more about eyes without minds. So the idea here is that most of the times, and in the examples that I give you before, where you're looking is a very good signal of what you're attending to. So usually we look towards the things that we want. We look towards the things that we're going to grab next, for example. We look towards the things that we're attending to. But this is not always the case. And I'm going to show you a case study where gaze is actually divorced from intentions. And to illustrate this, I'm going to play this clip from a recent Netflix series that in the US was very, very popular and is probably responsible for everybody playing chess now. So this is a chess champion. She's at a competition. She's getting into the elevator. She goes in the back. Now her competitor walks in and they're talking about her and they're saying some things that are not really nice. So of course she's staring at them from the back of the elevator. And now watch what happens. Okay, she got caught staring at him and it was pretty awkward for everyone involved. So what we're interested in is this phenomenon of getting caught staring. And in particular, the idea that when you get caught staring and you turn away, you quickly look in another direction. And it really doesn't matter what you're looking towards once you turn. What all that matters is that you are turning away from the other person. So this is a case where the direction where you're looking is not what you're attending to. You're actually attending to the other person and you're turning away from them. And so we think that this is a really interesting case study where gaze is divorced from intentions, and we were curious whether people are sensitive to this dissociation and whether the importance of eyes and of gaze would break down when they're not actually signaling any pattern of intention and attention behind the gaze. So we decided we were really interested in this, and this is work that I've done with Brian and Icha, who's a postdoc at UCLA and it's collaborated with me on all these studies of deflection that I'll show today. So we took perhaps the most common phenomenon of gaze, which is gaze following, the idea that when somebody turns to look in one direction, we follow their eyes and we follow their gaze and we automatically look in the direction that they look in. And so the question is whether we still follow gaze when it's deflected in this way, when it's not signaling any pattern of attention or intention. And of course, we couldn't show people Netflix movies, so we created our own animations featuring me, Icha, and then another one of me. And then Brian told me I had to stop and I couldn't put 3 of me. Okay, so what happened there is Icha started staring at me, A is looking at B, and then she got caught. So I caught her staring and she quickly turned away. Now, you might have seen that a target appeared in the animation in the space between Icha and I. And this first target happened as she was intentionally staring at me and looking at me. And so we call this a directed gaze because it's actually signaling some pattern of intentions behind them. Now, for other participants, the target actually appears in the direction of the deflected gaze. So after Icha has turned away, and of course, this is the opposite. This doesn't signal any underlying pattern of intention or attention. And so the question is whether the discrimination for this target, so some people saw an L, some people saw a T, and then they were asked to tell us whether they saw an L or a T, would differ between the directed and the deflected gazes. And so what we get is just the percentage of accuracy in discriminating the T or the L. And we find that people are much impaired when the target appears in the direction of the deflected gaze as opposed to the directed gaze. Now, of course, this target differs in a number of ways: the location, how many people are looking in that direction, and when they appear. So we ran a series of controls where, and the logic underlying this control is that we take the same exact animations, but we flip the position of the actresses, we mirror them, we cut and crop the frames such that you get the same exact head motions. They're the same exact movies, but shuffled in a way that you disrupt the perception of deflection. So here's an example where Icha again turns towards me, and then she turns away, but she never got caught because I only turned later. And so if you compare this to the animations of deflection that I showed earlier, these are the same exact frames, they're just rearranged in a way that disrupts the perception of deflection, and then both targets appear to be directed in that way. And what we find is that the difference between early and late targets goes away. And then this is just, again, a direct replication. We also do this with the actor. I keep saying the actresses, but actually it's just me. So with the people facing forward, where she looks at me and then she gets caught and she turns away. And then here's another example of a control where I actually start facing the other direction, and then she turns the other direction, so she never actually gets caught. And again, we find this pattern where the target discrimination accuracy is much lower for the deflected target. And across all these experiments, we control for everything. We control for everything that we can think of. We control for the number of turns, the timing of the turns, where the turns are happening, who's looking at how many people are looking at the target at any given moment, where the probes are appearing, when the targets are appearing. So yes, across all of these experiments, the pattern that we find is that the attention of the other person, whether it's directed or deflected, really matters for whether you follow their eyes. Now, I want to show you this movie one more time. Let me see. Sorry, I want to share something else for a second because I want to show you this. Okay, let's watch this movie now. There's no sound. Okay, so same exact thing as before. Icha looks at me and then I catch her and she quickly turns away. Except the movie that you just watched, despite eliciting strong percepts of deflection, was very different from the ones that you saw before, because Icha and I actually turned at the same time. And so while in deflection, usually I turn first and then she turns the other way, there's a very clear temporal order here. In other cases, in the video that you just watched, we actually turned at the same time. The thing is that most people, and you might have experienced this too, perceive deflection instead of synchrony when they watch the synchronous animation. So despite Icha and I turning at the same time, they perceive me as turning first and catching her staring. And we noticed this while making the animations because I thought I had done something wrong, but actually I kept getting the percept of deflection even in the synchronous animations. And so we ran an experiment on this. We just showed people the synchronous one and we asked who turned first. And the main finding is that people who watch the synchronous animations consistently report having seen deflection. So having seen me as turning before Icha, even though actually we turned at the same time. And then you compare this to animations where actually Icha was facing the other way when I presumably caught her, and the effect completely goes away in this control animations. And here's just a direct replication of this effect. Now, you can also ask this in a much more direct way, which is instead of having them select who turned first, you just ask them to describe what happened. And then we coded their descriptions for what they were saying was happening. And what we find is that most people in the toward B animations describe me as having turned first, even though in fact I was turning at the same time as Icha. And they'll say things like, she got caught, and so she proceeded to look the other way, or when she notices, she turned the other way, as opposed to the control animations where people mention things like turning at the same time or simultaneously or in sync. So we think this is pretty interesting, because it means that the percept of the social intentions and the social attention in a way overrides what you might think is much simpler apprehension that you get from this animation, which is the impression of temporal order. This is just a direct replication. So instead of synchrony, they see deflection. Now you might think, okay, maybe they're just reporting, they're not actually seeing deflection, they're just reporting what makes more sense, what is most likely, what they have seen before. And so to make sure that they're not just saying what they think is most likely, we ran another experiment where we replace the animations with descriptions of what happened. So this is the same exact head movements, the same exact order, but instead of watching the animations, these participants only saw the descriptions. And then the question was, for those who watched the animation, who turned first? And so this really helps us get at whether these people have an idea of what should happen or what is most likely to happen, or whether it's really the visual stimulus that matters. And so we call this the blindfold test, because effectively we're blindfolding our participants, and we're running the same experiment by removing the visual stimulus and seeing if we get the same effects. And so again, we can compare the toward B animations with the control animations. And what we find is that people, again, select deflection much more often in the animations. This is just a direct replication of the experiments you've seen before. And this doesn't happen when they're just reading the description. So this really highlights the importance of the visual stimulus in this case. Okay, so instead of synchrony, they see deflection. Now, we decided to take this one step further, and instead of showing the synchronous animation, which are still ambiguous, we asked whether we can actually reverse the effect. And so some participants watched animations where B actually turned first. So this is the classical deflection animation that you've seen 1,000 times now. And we compared this to animations where actually A is really turning first. And what we find is that, okay, people who watch B first are very accurate in saying that B turned first. And then this accuracy goes down when the correct answer is that A turned first. So the idea is that even when A turns first, they still perceive B as turning first half of the time. And again, we ran a direct replication of this. And so we think this is pretty powerful, because it means that even when the animations are reversed, they still see deflection. And so deflection, in a way, really can reverse the order of events in which you perceive them. I see a question from Matthias.
Yeah, how many milliseconds? What's the difference in milliseconds?
This was 5 frames, so that's 150 milliseconds.
Okay, yeah. Thanks.
Can I also ask a question, Clara? So,
yeah,
so I'm just thinking about like relating the second set of results to the first set, where you show the deflection abolishes the target priming.
Yeah.
It feels like this would be a particularly strong contrast case, because if they're both synchronously looking somewhere, then that might be a particularly strong intentional cue. It's like a noise happens over here, so both of us turn our heads, right?
Absolutely.
I'm just wondering whether, like, in the explicit reports, they seem to perceive deflection, but I'm wondering for target detection, would you expect it to reverse, or how does that look?
I love this question, because that's actually something that we're pursuing now. So one thing that I noticed in the descriptions of the animations is that when the people turn at the same time in the control animations, and people actually perceive them to be turning simultaneously, something people say in the description is, they turned at the same time, there must have been a noise or something must have happened for them to turn the other way. And so I think this is fascinating because the idea is that the intention and the attention, or your explanation for why things are happening, kind of creates an illusion of something that must have happened the other way. And so my prediction from reading these descriptions is that people would actually hallucinate targets given the intentions. And so that's work that we're doing now. Thank you for that. Okay, I'm going to move on to other experiments and close the chapter on deflection. But before I do, I just want to pause on this for a second and note how even the simple case study that is gaze deflection tells us something that I think is pretty meaningful about social perception. It tells us that social perception is sophisticated because it extracts the intention and the attention of the person behind you, in front of you. And it tells us that social perception is powerful because it can even reverse your impression of time and your impressions that you might think are much simpler and easier to form in this case. And it also tells us how social perception might be really automatic and something that we engage in so easily. So participants in our experiments do one trial typically. They come in, they have no idea what's going to happen. They know nothing about deflection. They are just told to watch this video, and then they're asked this strange question about whether they saw a T or an L. So really, they're never asked anything about attention, direction of intention, the relationship between these two people. So, and we still find the effects. So we think that this is an interesting case of analyzing everyday life behavior without never priming people or asking people these questions directly, and an interesting case where vision science connects to everyday life and experiences of everyday life, like gaze deflection, that are so common. And so we might all remember how awkward it is when you get caught staring at someone, can actually inform vision science and tells us something about how our visual system perceives other people and how our visual system operates. I see a question from Axel.
Yeah, I'm not sure if it's fully well formed as a question, but I was just wondering about demand effects. So of course you're asking people to interpret the intentions of the people who are featured in these videos, but what do you think they think about the intentions of the experimenter in these situations? So perhaps to attribute the perceived synchrony between the two movements of the protagonist's head as a fluke in the video, something like that, rather than, so maybe they misperceived, and actually what should have happened is that is a deflection scenario. And the video wasn't exactly like that, but then they sort of place more faith, which is interesting in and of itself, of course, in their sort of higher level interpretation of what the situation should be or could be, rather than into the perception. So, and I was wondering, would it be possible to test this simply by telling people, well, here's what happens in these videos. Now express these same judgments of synchrony with people who are aware of the nature of the manipulation.
Yeah, so I have 3 responses to this. The last one is going to be the most important. So first of all, so first of all, the reason we ran the blindfold experiment where we show those videos, and where instead of showing the videos, we just tell them what happened, was in part to test this. So in part to see whether people would give the same response when they know what's happening, but they don't see what's happening.
Of course, that makes it very ambiguous there.
Yeah. The second thing is that we actually directly ask people what they think that the experiment is about, and we exclude anyone who mentions order of head turning and looking directions. And so not only do we exclude them, but also we look at the rates, and they're really low in all of these experiments. So most people think that we're testing some sort of ad or like some sort of like a movie thing. So they really have no idea what these experiments are about. And third, in all of these experiments, they only do one trial. So they really don't know what question they're going to be asked later when they see the movie. And so all that they can do is just report what they felt during the movie, because they don't know the questions that they're going to be asked later. So the T and the L are surprises for them. Does that answer your question?
Yeah.
Thank you.
Okay.
But another thing I want to say about that is that we really care about that. So in most studies of attention, the question is, what was that person attending to? And the manipulations are very clear. But I personally really care that it's not a demand, and that this is actually something that happens to people as they just go about their daily life. So thank you for asking that. Okay, so I've started this talk by saying that people are important and their faces are important, and not all parts of their faces are important, but the eyes are more important. Now, I lied, because there's also one other level that we can go at, which is even within the eye, there's some parts of the eyes that are more important. So when you look at somebody's eyes, I said that that was important because it gives you an indication of what they're attending to and what they're perceiving. But really, not everybody is worth our attention in that way. So there's sometimes where you might be looking at a person, but they're really distracted. They're thinking about something else. And I'm going to really focus on the second part of my title, of the title of my talk now, which is attending to attention. And so the idea that when you look at someone, you can pretty easily and readily tell whether they're paying attention to you or whether they're distracted. And one cue to this is the size of their pupils. So the idea is that when people are engaged and they're attending, their pupils dilate. And this is actually kind of ironic how in vision science, pupillometry has been extremely pervasive. People use this as a method to investigate everything from attention to working memory to long-term memory, and not just in vision science, but also in development, in social psychology. And so really here, pupillometry is a method. It's a promising tool for investigating another person's attention. And now we thought, well, if pupillometry is so helpful to scientists to figure out whether somebody is attending, might it also be helpful to us in everyday life? So might we be engaging in pupillometry as we go about our daily lives and looking at people? So what we did is we took stimuli and we conducted digital eye surgery to make their pupils either constricted or dilated. And now, of course, we didn't want to show the stimuli to people as they were attending to them, just because, of course, the manipulation is pretty clear. So we actually presented the stimuli in a way that was outside of their awareness. And we do this using a method called continuous flash suppression. So the idea is that we have a haploscope like this that divides the input to the two eyes. And so on the one eye, we show the face that has either constricted or dilated pupils. Here it is. The problem is that it's invisible because there's flashing masks appearing to the other side that cover the face. And so subjectively, the experience that the subjects have is that they see the flashing mask, and then at some point the face appears, and their task is simply to press up or down to indicate the location of the face as soon as they see it appear. And so we use different stimuli with dilated and constricted pupils. And we really want to make sure that this is not something about small or big or dilated black dots, but it's really something about a socially meaningful stimulus. So it's really something about the pupil and not just smaller versus larger dots. So what we did is we took a non-social control that looks exactly the same. So we took the pupils and we pasted them on people's shirts that we had previously matched to be the same hue as the iris of the people. And then the question is, do we find an advantage in the entry into awareness for black dots when they're socially meaningful and they appear as pupils, but not when they appear as buttons? And so when we measure the breakthrough time of the stimuli into awareness, we find that dilated pupils break through awareness much faster than constricted pupils do. But this doesn't happen with the same exact stimulus when it's in a location that's not socially meaningful at all. So one thing that you might be thinking is, well, of course, the people are gonna maybe attend, these are the same stimulus, but people maybe attend to other spaces, even subconsciously, more than they attend to shirts. And so what we did is we took the same stimuli again, but we pasted on people's faces, actually pretty close to the eyes, as facial moles. And again, we compute the breakthrough time, and we find that this is just a replication of the previous effect, where dilated pupils break into awareness faster, but dilated moles don't. And so the idea here is that it's really the social meaningfulness of the stimuli that makes them break through awareness faster. And another thing that I want to know is that we asked our participants after the experiment what they thought it was about and how they thought the faces were changing over the course of the experiment. And only 2 out of 60 mentioned the people's pupils or the people's eyes. And even within those 2, they couldn't point to the pupils as what was changing, but they were saying something about the eyes was changing. And so really, I want to emphasize how visually subtle this signal is. So somebody's pupils being constricted versus dilated is obviously a very, very small degree of visual angle, but it makes a lot of difference for the overall expression of a face. And in fact, in other experiments, we directly ask people, what do you think the difference between this face and this other face is? And despite the pupil being what's changing, people would say things like, well, they look happier, or their overall expression is changing. And so we think this is another example of how social perception can be powerful, because when even a change that's so subtle, when it signifies something so meaningful about another person's attention or perceptual state, it really becomes a big part of how we see them, and even outside of awareness, how fast they will enter our awareness. And this is also some form of attentional contagion, because when you perceive somebody who's attending and whose pupils are dilated, they will enter your awareness faster. Okay, I'll go through one more if there's time. Yeah, this is going to be quick. This is very new work that we're excited about. So I've talked about deflection as a case where you're looking at something versus away from the same thing. And so it can help us divorce attention and intention. I've talked about dilation as a form of attentiveness versus distraction. But there's another case where you might be perceiving somebody who's actually attending very closely, but what changes is what they're attending to. So whether they're attending to the external world or the internal world. So this last project investigates whether our perceptual system automatically computes whether somebody's attending externally versus internally. And the idea here is that when we talk about attention, there's some forms of attention that are directed to the external world, like detecting features, detecting objects, and other forms of attention that are inwardly directed, like long-term memory, working memory, or task rules, or deciding when to respond. Okay, so we were looking for a case where the same eye movement and the same feature would either signal external attention or internal attention. And this case is looking up. So when you ask somebody to look at something on the ceiling, they're going to look up and their attention is going to be externally directed. But when you ask them, for example, to solve a math problem or to retrieve a memory from childhood, one thing that people do is they look up. So the idea is that you want to disengage from the external world and look up to focus inwardly. And so here, again, just like in deflection, we have the same eye movement that can either signal a focus on the ceiling, a focus external, or focus an inward focus. And so we recorded these animations where my lab mate Stefan is asking me a question.
I have a question for you. Okay. Who painted that piece of art on the wall over there?
Kandinsky. Okay, so the question that Stefan asked me is who painted that piece of art on the wall over there? Now, in other animations that looks exactly the same, we changed the audio track so that the question is not who painted the piece of art on the wall over there, but the question is who painted that piece of art that we saw in the museum. So one case requires me to look up and look at the wall and look around. One case requires me to think inwardly and retrieve a memory. And then just like in deflection, we flash these targets and we look at how good people are discriminating them. And what we find is that gaze following, people's ability to follow the eyes of the other person and discriminate the target, is impaired when that person is focusing inwardly. And the idea here is that it's not worth following somebody's eyes if they don't actually mean anything about their mental state. And we also replicated this with another set of questions. That's what kind of bug is on the wall over there. The wording of these questions, we spent a lot of time on it to make them equated, but they're kind of hard. So, and then the other one is what kind of bug is that we saw at the store. And so again, one requires me to actually look around and look for the bug, and the other one simply requires me to retrieve a memory. And we replicate the effect again, where cueing is impaired for this sort of internal, when the other person's attention is directed internally. Now, there's more work we have to do to show that this is actually real. One thing that we're doing now is that instead of having the person turn, the person is totally still, and we find that the effect goes away. So the idea is that it's not the participant's attention that's being directed externally or internally, but it's really the gaze cue that's driving this sort of difference in this sort of effect. Okay, so I hope that across all these cases, I've convinced you that other people's attention and intention are important, and that our ability to extract other people's intentions is really sophisticated, because it really follows the mind behind the eyes rather than the brute visual features that might drive them. And also that it's powerful because across all these different paradigms and these different types of DVs that we get, we find effects of minds rather than effects of eyes. And so with that, I'd like to thank my lab and my advisor, Brian, my committee, and all the collaborators on these projects, and also the people who've been my stimuli for all these years and that you've seen in this talk. And thank you very much for your attention.
Okay, let's all mute ourselves and give Clara a big round of applause.